Hello everyone, in this tutorial we will modify our ocean to use with the beach scene. And this tutorial only focus on the ocean, not entire landscape. We will create the transparency water and the wave is higher when it is near the beach. And we add the caustic, also improve the water line or underwater volume to be more accurate. I would like to tell you that this water wave only move in one direction, so you cannot create entire island with this water system in this current state. Continue from the last tutorial. Open the effects and this FX ocean water. We need to duplicate this to create the near beach ocean water. And rename it to FX ocean water beach. Open this FX ocean water and set the short wave to multiply it with 2. Y multiply with 2. 2 multiply with 2 is 4 and 60. And modify this amplitude. We want the wave to be lower. So this divide it by 2. And 240 divided by 2 is 120. And save this. Open FX Ocean Water Beach. Set the wind tighten to 10 because we want the long wave for this wave that is near the beach. Patch length is, this one is 56. This amplitude, we want the wave to be higher wave. And foam injection 0.65 for all of this. Threshold is minus 0.05. And the foam weight is 0.15. Foam blur 0.5. We can change this wind speed to 100 to make it the wave appear faster. And we need to change this render target. Open this render target and all this pixel. Create new folder. Name is Pixel Beach. Select all this render target. Duplicate. Ctrl D. And move it to Pixel Beach. Move here. Rename it to as B. B. 1B, 2B, 3B. And this ocean pixel attributes B is casserole B, 1B, 2B, and this one is 3B. And this roughness is roughness B. And add new folder is vertex B. Open this vertex, duplicate this, move it to vertex B. Move here, rename it to attribute B. And go to FX Ocean Water Beach Niagara. We set this to the new render target. This row B, 1B, 2B, 3B, and the vertex attribute B, this green one. The same as before, just with ocean pixel attribute B and casserole B. And this roughness, OT roughness B. Save this. Let's add this Niagara system, the new one, to the scene. Set location to 0. And see this render target beach. It have the new render target. We add the landscape. Go to landscape and set this to 0. And we only want a small landscape, so only one component. And then create. Delete this. Both. Move this water up. Set it to 0. And you can scope this landscape. The strength, set it to 0.1. If you want to scope it down, you can press Shift to scope it down and click on the landscape. And to smooth this out, you can use this smooth. But I already have the landscape. I can use the old landscape. This is the landscape that I already sculpt it, and move this down to minus 330. Go to BP water ocean and get this as size 10,000. And the file distance, you need to set it to 10,000 too. Compile. We have largest surface of water. We add search for player start. Drag it on the landscape. And go to world setting. Set it to BP third person game mode to spawn the third person character. Let's play this, and we have the third person character. You can adjust this scalability, set it to high. If your frame rate is low, the low frame rate may caused by this underwater, so we temporarily disable this. Now it's plays smoothly. Go to the material and duplicate this ocean water material. Preview ocean beach. Open this. We want this water to be transparency. Set it to setting model is single layer water. We need the single layer water material. Output. Create 4 vector. And we can convert it to parameter. Name is scattering. Set R1, B1, G1, and alpha is 0.5. Multiply with this alpha and divide it by 1000 and connect to scattering coefficient. Click on 4 and left click. Set R to 10, G 100, B 500, and A is 8. Then divide 1 divided by this. Create convert to parameter. Rename it to absorption. And divide by alpha. Connect to absorption coefficient and phase G that is to 0.8. Change this specular to 0.5 and change the opacity to 0.8. Apply, save this. Go to ocean and BP water ocean. And this child actor. Let's set this rendering. Change it to the new material. And this ocean have the transparency. Let's walk this character into this ocean. You can see the leg of the character. If you want to have more transparency, you can adjust this transparency. If you change it to 0.5 and apply. Next, we want the ocean wave that is near this landscape have different type of wave. Go back to material and move this. MF, grab pixel attribute. We need to change this to beach render target. So this MF grab cascade data vertex, duplicate, and vertex B. Open this. And set this render target to vert attribute B. And change to this one, the near beach wave render target. Next is this grab pixel attribute, duplicate attribute B. Open. We change this render target to 0 B. And this one. Apply and save. This grab vertex attribute, duplicate, name these two grab vertex attributes B. Open. Change this to grab cascade data vertex B. Apply. Save. This underwater. Duplicate this, both of this. Name it to post B. And this to post B. Change this to vertex post B. And we save all. Go to preview ocean beach material and we can set this foam texture size to 1000. Set it to 1000. Copy this as it and comment on this. This is water body. And this is beach or shoreline. First thing we need to adjust is this cascade size. Let's see our Niagara. This effect, FH ocean water. This patch length is the cascade size. So it is 28 for Y. This is correct. And this cascade size set it to 2. And see the FH water beach. This patch length is 56. So set it to 56. And I need to adjust this value, this scale to 7 because I want the larger whale and set this to 4. And we need to love the color. Create a linear interpolation between this base color with this color. Connect it to base color. Copy. And this normal with this normal. Connect it with normal. This bubble mask with this bubble mask. Connect it to MF scattering bubble mask. Create world position and find distance to nearest surface. Then divide this with 200 for the distance. Clamp from 0 to 1 for cheap contrast and set it to 0.8 for the contrast and connect it to this alpha. Apply, save. To make it obvious, we can set this to red color for A and go to our scene, and you can see when it is near this landscape we have this red color. Let's change back to this near beach material. We need to change this grab pixel attribute to grab pixel attribute B for the beach and grab vertex attribute B and apply. And now we can see this have different material for near the landscape. Next, we need to change the world position offset of this near material. Let's create another material function. Name is mf near to surface beach. Open this. Create input vector 3. And this is vertex attributes beach. Another input function. Name is vertex attribute ocean. And we need to loop between these. The beach and the ocean. World position. Distance to nearest surface. Divide it by the distance. Set it to 300. And then clamp 0 and 1. Add cheap contrast. Set it to 0.5 for the contrast. And connect it to this alpha. And the beach, clamp the high minus 20 and this max is 100 because I don't want it to the wave to be deep. It causes the collision with the landscape. And create another linear interpolation. Get this result by add with 2.7. All this value is depending on your result that you want for your landscape. So you can adjust it with the value that you desire. And divide by 5. Let 2a and b is this result. And the world position distance to nearest surface divide that is to 40 the distance and clamp 0 and 1 keep contrast to 0.5 and connect it to alpha. I want to flatten this wave when it is nearly collide with the landscape. So connect it to output. This output we name it to world position offset. Apply and save. Let's go to material. We can change this ocean priority to 1 to make sure this is the second input when it display in this material function. Function call and this vertex attribute ocean is the second. Like this. And this beach vertex attribute. Connect this world position offset. Apply. And let's see this. Play. And we can see the world offset is different for this wave that near the beach. If you want this wave to have more height, you can go to this average ocean water beach and change the amplitude. Let's set this to higher, multiply by 2 and let's save. And we have the higher. And close all of this. Next, I want to create the material for the sand. Go to Quicksaw Bridge. And I use this Icelandic sandy gravel. Download and add it to the engine. Go to content and add another folder named beach. Create material M sand. This is just the placeholder. If you want the material to look more realistic for the landscape, you can follow Unreal Sensei material tutorial. To Mega Scan and Surface Icelandic. drag this inside the project. X coordinate, divide by 2 for UV to scale this texture. Connect it to base color, or for ambient occlusion, G for roughness, and B world offset position. And connect this to normal. Apply. And go to detail, not world setting. Search for material. This landscape material, let's set this M sand. And when we play, we can see this material or this set and duplicate this. I want the sand to have the sand that is wet near the ocean water. Rename it to M wet sand. Get world position, mass B for the height of the world position. Then subtract with minus 300. Add. Copy this world position. Get the noise. Multiply with 25. Now you to add. And we create a high lobe. The contrast is 0.1. And we get this color, base color of this material. Multiply with another dark color. Make it to A. And another one is B. Connect to base color. And this is the high texture. Alpha called linear interpolation. We want the roughness to be lower to appear to be the wet sand. Multiply it 0.5. It to A. And the normal. Connect it to roughness. Change this material to this wet sand material. And you can change this to darker. color. Let's disconnect this noise first, and we will adjust this noise later. And this is the sand line, the wet, and I want to add the noise to this line. Change this noise scale to 0.00025, and disable this turbulence. Set level to 5. Output max is 2, and apply. Here you can see the noise for this sand. And we adjust this color, and this is the roughness that you can adjust. Now we want to add the caustic for the ocean water. Let's add new folder. Name is Caustic. And import the texture that we will use. This water caustic and water normal. And next we create material M Caustics. And in this water line, we can import this pulp water and import all. Delete this material. And save this caustic. Create texture sample and use this water caustic texture. Change this material domain to differ decal and change it to translucent. Get first position, multiply by 0.006. Create a panel. Speed is 0.24 and 0.12. Multiply 0.6. Multiply with 0.5. And connect to multiply. And use this as UV. And then we multiply this with 0.7 and connect it to emissive color. decimal position. We can mask this. Or G. Connect to coordinate. Compile. And we drag this material. We can see this texture is moving. We duplicate this texture. And then add call another panel and change the speed. X is 0.24, Y is minus 0.12. Multiply 0.66 multiply with 0.5 and connect to this B. And we connect to this UV. And we have the two texture that moving in the different direction and have different scale. Next, we want the distortion. This RG, create a panel. Move it down here. Multiply. Copy the multiply. 2. Multiply with 0.5. Call texture sample. And use this normal texture. And multiply. With the value is 0.015. Mask RG. Then we add with this panel. Add with this too. And connect to UV. And apply. We have some distortion with this decal. And if we add a coupe here, you can see this vertical, it have the straight decal on it. So we don't want this. called mass component mass. This one is GB or B and or G. Per normal thin texture change to per normal, and this color called absolute round mass G and mass B. Then for linear interpolation, connect this with the alpha and another one with this alpha. Move all of this to here. Apply and save. Let's see if this is working or not. Now it is working. Let's delete this. And we want to add this decal to our water, ocean water. Add decal. And set this material, decal material. And we scale this decal depending on the ocean. Move this down. And we can use this get tile size copy in the construction script. Get decal and set relative scale 3D. Click this and connect it to X and Y. Get decal, set relative location, click, get relative location from this decal, and we get X to X, Y to Y, and Z subtract with 145 to Z and compile. Don't forget to scale this Z to 140. And we need to set this decal size to 1, and lock this first, set it to 1 for all. And we can see this ocean, we have the decal. under the water. You can adjust the strength, the brightness of the decal by changing this multiply value to lower 0.4, and we have lower brightness decal. Next, we will improve the accuracy of underwater material post-processing. Waterline material function name is MF beach displacement. Go to material, this M preview ocean beach, and we copy this. Shoreline and this water body. And this vertex attribute function call search for near to surface beach and near to ocean and beach, and this will offset to output. We create another material function, duplicate from this MF beach displacement post. And use grab vertex attribute B, this post B, grab vertex attribute post, function call push get flip plane next to position and this to position, and we mask this, only use B, copy and pass here. Apply, we save all, can go to material function and we can delete this line because we not use it anymore. For this material, delete TP line, and this material we change to TP value half, and this material instance we can delete all of this. Add a new folder, name is post process, and move this to this post process. Add new folder is scene capture material. This one is post process material. Create a new material, name is M waterline hoop mask. And another one is M waterline plane, and create render target. This texture render target RT water volume. Open this waterline cube mask. Set this blend mode to mask and unlit. Set W to 1 and call linear interpolation. Another one is 0 to sine next to alpha. Convert to parameter. The name is water high. And add to 5. Add material function call use beach displacement like here. Then mass is only B. Subtract world position mass B. And connect to subtract. And connect this to opacity mask. And this to emissive. So apply and use two side material. This material, the thing that inside this material it is white and outside it is black. Go to water ocean and add static mesh. The name is cube and use this cube border. This cube border don't have the top of it. And search for collision. Set the collision to no collision. Lighting. We disable this affect distant field lighting because we don't want it to affect the distant field of near distant to surface material. So disable this. How? And let's set the material. Use this material. . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . waterline cube mass. And we need to set the scale of this cube to the water actor. Create this sequence. And we can copy this water mesh size, get cube, set relative scale 3D. X and Y. And the size we can divide it by 100 first before connect to X and Y. And the Z is 20. Get cube. Get relative location and split this. Set relative location and split the location. Z subtract with 19 multiplied by 100. This is the scale, but I want to set the scale it's a little bit smaller and multiply by 100. Like to new location, X and Y. And we add another pin or create dynamic material instant. Use this M waterline cube mass. And promote to variable. Variable name is waterline cube mass. Get waterline cube mass and set scalar parameter value. Set this parameter name to water height. And we get actor location. Use Z as the value of water height. And get cube. Set material. Get waterline cube mass next to the material. Half, tail. And you can see around this water we have the cube that inside of it is white and outside is black color. This is the border for our underwater. Set M waterline plane. and value is 1. Linear interpolate between 1 and 0. Search for full size sign and set it to alpha. Set it to unlit this setting model and tool size material. Like to emissive size, emissive color. Function called pitch displacement. Next to world position offset. Apply. Open this multi-water volume render target and set the size X to 1920, size Y to 1080. RTF change to RTF R8. Save. Go to BP Water Ocean and add a child actor. This one we can name it to water actor, and this child actor name is underwater layer, and search for water actor. We want this water actor is exactly the same as this water actor, or you can just duplicate this water actor from this one. It's the same. So delete this and change this name to underwater layer. Go to render. The tile size is the same and tessellation the same. To render and this water material, set this to M waterline plane. The far distance set to this waterline plane. Compile and go to ocean and see if this is the same as the last water actor. So it's overlap each other. It is exactly the same height with the water actor of our ocean. Next, we click on this deposit route and add scene capture component 2D. Choose the texture target is this RT water volume, and we use show only list. We change this to RGB 0 in A, no opacity. Go to advanced and this show flag. We disable all of this. We only want to show the static mesh and disable all of this. Grass, instant static mesh, post processing, show flag, lighting, sky lighting, disable, ambient. This nanite show flag disable. Rendering is visible. After doing this, we still need to set the flag setting because when we close this project and then load it again, this show flag will not work correctly. I think this is the bug. So let's add variable. Name is engine show flags. Set this variable type to engine show flags setting. Set it to array. Compile and add this array. Go to scene capture component and use all of this as the variable array. Anti-aliasing is false. So write in this anti-alias. You have to type it exactly the same name. It is false. Next is atmosphere. BSP to fall. Cloud decals. Fog landscape. Particle sprites. Skeleton mesh. This. Static mesh. Set it to true. And translucent is false. Go to construction script. After that, we set this engine show flag, get engine show flag, and get scene capture component. Set show flag settings and set this array next to the sequence. File and like this. We can copy this and as it use in the begin play and delete this and create a sequence. Get player character. Set owner. We need to select what is visible in the scene capture component. We only want this cube and this underwater layer to be visible. Set it to new owner. Get this cube show get this scene capture component or show only component, and this is the code component. Set visible in scene capture only. Set the value to true and get code. Set owner no see. Set it to true. And this underwater layer, get child actor. As full water actor. And get water mesh. Get scene capture component 2D. Show only component. Set this in component. Set visible scene capture only. Set the value to true. Next, we set visibility. Set it to true. And get player controller. Player camera manager. Transform component. Attach component to component. The target is scene capture component 2D. And attach to this parent. Snap to target. And compile. Let's play test. And we go to the ocean. We not yet set the volume, post-processing volume to this new render target. First, we set this to visible. Disable the visibility. This visible of the water mesh, not this rendering. Go to post-process material. PP volume. Delete all of this. Add this water height to 20. And function call base displacement host. Mass B. And add it with water height. Camera position. Component mass B. and subtract with this water height and clamp 0 and 1 connect to this alpha. We need to create a texture sample. Use this render target water volume and love with the black texture and with this. We create this alpha because we want the volume to disappear when it is outside the water. So let's play test. And now when we go under the water, we can see this volume and the water line is more accurate than before. Set this to brighter color. But we have some problem with this volume because when it is near this water, you can see this a little bit of blue color. It's come from the cube that is not completely correct with the mass of the water surface. After we adjust all of this, the buoyancy will not correct because we have different wave setting. So go to effect, open this ocean water FX, and you need to go to this ocean C++ file, ocean FFT data. This short wave cutoff is 0.2. We multiply it by 2. And this one is 60. You need to compare it with this setting. And another place is ocean FFT calculator.h. Make sure the scale is the same, 3, and overlap scale is 16. Go to material and this beach. See the scale 3 and 16. After you do this, you have to save it. Close this project. Run this again. Let's add this buoyancy. Open this. The static mesh. Set disable this effect distance field lighting. And we don't receive decal. play, and this buoyancy only accurate in this sense, the ocean wave, not this shoreline wave. This is the end of our tutorial. If you would like me to continue this water ocean tutorial, please let me know in the comment section below. Thank you very much for all my patrons members who are supporting me. Your support really means a lot to me. Thank you very much for watching. See you in the future tutorial.